Hello guys, this is Amrit Manandar on behalf of Cloud IT Tutorials. In this video, I am going to discuss about ipv6 address and its different types. Let's start our video. ipv6 is the Internet Protocol version 6 address and is the most recent version of Internet Protocol. It's the communication protocol that provides the identifications and locations of the systems in our networks, like our in-user devices and in-network devices. It's the routed protocols like ipv4 and is the successor of ipv4. To deal with the ipv4 address exhaustions, ipv6 was developed by Internet Engineering Task Force. We know the limited number of ipv4 address public IP block is getting exhausted and the number of internet users are growing exponentially. ipv4 uses a 128-bit address, theoretically allowing 2 to the power 128 number of IP addresses, and it's nearly equals to 3.4 into 10 to the power 38 addresses. While ipv4 address just uses 32-bit addresses and it provides approximately 4.3 billion addresses. The two protocols are not designed to be interoperable, but so complicating the transition to ipv6. However, several ipv6 transition mechanisms have been developed and been devised to permit communication between ipv4 and ipv6 hosts. ipv6 addresses are represented as 8 groups of 4 hexadecimal digits, with each group being separated by colons. This is example of ipv6 address, and each group is the combination of 4 hex digits separated by columns. This is the decimal, hexadecimal, and binary table. 4 binary bits is used to calculate single hexadecimal digit. As you can see, this 0 is represented in binary bit 4 binary bits that are zeros, and 1 is represented by 0001, 2 is represented by 00, 3 is represented by 0011, and so on. Hexadecimal number starts from zeros and ends at f. F is equals to 1111, 0 is equals to 000, and 0. In this table, the preliminary bits are omitted because they are zeros. So 4 binary bits combination provides 1 hex digit. So total number of hex digits that can be calculated using 4 binary bits are 16. So if you count from 0 to f, they are in total 16 digits in hex. Now let's discuss about ipv6 abbreviation. This is ipv6 address and it can be abbreviated. It can be written as below. The zeros that are at the leftmost side, and if it is increasing at rightmost side contiguously, that can be omitted like this. This 0 is omitted here. Similarly, these 3 zeros are omitted here, and these 3 zeros are also omitted here. Again, it can be abbreviated in this way. Contiguous zeros in the group can be omitted and represented by a single 0. But it should be noted that to represent it as 0, there must be contiguous zeros in all 4 hex digits in the groups. So we can represent this 4 contiguous hex digit in this group also by single 0, and so on. Now again, it can be abbreviated in this way. If there are contiguous 0 in multiple groups, they can be represented by double colon. So this is correct. It can be also represented in this way because here is also contiguous zeros, so it is represented by double colon here. But the problem here is we can't use this double colon in more than one places like this. This is wrong. So either we can use double colon in this way or in this way. This is ipv6 abbreviation. ipv6 address is of 128 bits. Its first 48 bits is the global routing prefix, Its next 16-bit is subnet ID that can be used for subnetting. In later video, we are going to discuss about subnetting in ipv6. And the last 64 bits are used for interface ID. This represent the unique host part in ipv6 subnet. So, in total, this /48 global routing prefix plus this 16-bit for subnetting gives off 64 bits for prefix. So it is /64 here. And next 64 bit represent host part. ipv6 has three types of addresses and can be categorized by type and scope. First one is unicast address that is delivered that is used to deliver a packet to one interface. That is, if you want to do one-to-one communication between two nodes, we can use unicast address. Next is multicast address. If you want to do communication in between one to many nodes, but not all nodes, you can see here. This can be obtained using multicast address. And next one is anycast address. If we have multiple servers which are clone of each, and if we want to access that server, we first try to access the nearest one, and if it's down, we try to access other one which is nearer to it, and if it is also down, we again try to access next nearer server. This is obtained using anycast address. Packet is delivered to the nearest of multiple interface. Unicast and anycast address in ipv6 have the following scopes. Link local. The scope is the local link. It means link local addresses can be used within the local link only, so it cannot cross the router. This is link local address in ipv6. So its scope is within this link only. That is within this network which is connected through this interface of router. This link local address cannot get routed towards other interface of the routers. Next is site local address, and the scope of the site local address is within organizations, and it is private site addressing, while the global scope address is the global unicast address, and it is like ipv6 internet addresses. Let's discuss about it more in detail. Here we can see one picture. I have taken this picture from the internet. Let's discuss about multicast scopes. Node local means that's address whose specifications and whose scope is within single node only, that is within single device only. Next is link local. As we have discussed before, its scope is within local network only. It can work within single network only, but it cannot cross the router. Here we have router. Next one is site local, and within local site it can be used. This is the site local scope. For different site we use different site local address, and it also cannot cross the single site. Next one is organization local. Scope is within organization. If this is one organization, let's say it is ABC organization, the organization local address scope is within this organization only. And the final one is global scope address, whose scope is across the internet, that can cross this organization and travel within the internet. Okay, now let's jump forward. This is unspecified address in ipv6. It is represented by double colon and /128. The unspecified address may only be used as a source address by initializing hosts before it has done its own address. Its equivalent is 0.0.0.0 in ipv4. If this PC is configured to obtain IP by DHCP, when this PC first started, booted, or when it is connected to the network cable, either wired or wireless network, then at first it has to send request to the DHCP server. to obtain IP address from the SCP. But to send the packet, it has to use one source address, that is source IP address. At first, when it is just connected to the network, it will not have any IP address, so it uses this unspecified address as the source IP address to send the request to the DSCP. Next one is loopback IP. It is represented by double colon 1/128 in ipv6 and its equivalent is 127.0.0.1 in ipv4. This address is used when the host talks to itself over ipv6. This is often happens when one program sends data to another. You can see it is also known as localhost. When the data has to be transmitted within the router itself in its one NIC card from itself or from PC to its one NIC card itself, we use this loopback IP in IPv4 and IPv6. In IPv6, it is : 1. Next IP is unique local address. These addresses are reserved for local use in home and enterprise environment and are not public address space. Its equivalent is with the private IP blocks in IPv4. These addresses might not be unique. In IPv6, FC00::/7 represents IPv6 address for unique local addresses. In this block, there can be multiple private IPv6 addresses, and they are called unique local addresses. Packets within addresses in the source or destination field are not intended to be routed on the public internet, so they can be routed only with enterprise or organization. This is called unique local address, and scope is within organization only. Either that can be site local scope or organizational scope addresses. Link local addresses. These addresses are used on a single link and cannot be routed via routers. They do not need to be unique outside of that link, so scope is within this link only. So they should not be unique within other links, like same link local scope address can be used here and here because they are different link local scopes. And it is represented by FE0::/10 in IPv6, while its equivalent in IPv4 is 169.254.0.0./16. Next one is global unicast address, and it's like the IPv4 public internet IP block, but it has no equivalent single block in IPv4. This global unicast address can be routed within internet, so these have very vague scope like the public IP in IPv4. And next one is multicast address, like 224.0.0.0/4, that is class D block in IPv4. FF00::/8, its equivalent is for multicasting in IPv6 like in IPv4. These addresses are used to identify multicast group. They should only be used as destination address and never as source addresses. That should be noted here. So if this PC has to multicast using IPv6 and it has to send multicast packet to this PC and this router, then it will use this IPv6 address block. Thanks for watching our video. Please do not forget to subscribe our channel Cloud IT Tutorials. Thanks for watching.